All right, good evening, everyone. Happy Guy Fawkes Day. Anyway, so we've already gone through, I believe, 1 through 6 in class in one way or another. So what I'm going to do here is I'm going to walk you through a couple of these just to make sure that you guys have that extra level of assistance and hopefully get you guys in a position where you're ready to move on. So let's go. We're going to start off with number 9. Now remember, before we even get to step 1, we need to make sure that we're in standard form. Standard form, ax squared plus bx plus c equals 0. So because we have a 7 there, we're going to subtract 7 from both sides. That's going to give us 7p squared plus 30p plus 8 equals 0. Now we're in standard form. Step 1, we need to identify our a, b, and c. Now look up here at the standard form of a quadratic equation. Notice that a is the coefficient of x squared, meaning it is the number in front of the x squared. So a lot of people want to say a equals, in this case, 7p squared. When in fact, a equals 7. Because notice we put the 7 right there. We put the 7 where the a was. We don't replace the x squared or the p squared or the n squared or whatever the squared term is. So when we're talking about a, b, and c, it's just the coefficient. So a equals 7, b equals 30, c equals 8. So what we're going to do is we are going to now go to step 2, which is multiply a by c. 56. Step 3. We want to find all of the factors of 56, the factor pairs of 56. Again, that simply means what two numbers are multiplied by each other to get 56. And then they need to add up to 30. So we have 1 and 56, 2 and 28, which is going to be our answer. But I'm going to go through and finish this up. Now, what I want you guys to understand is that sometimes this is really easy and it'll be something like that. And other times, like the ones we did in class, you're doing factoring for, 902, whatever that number was. And on that, you just have to sit there with your calculator and go 920 divided by 1, 920 divided by 2, by 3, by 4, by 5, until you get the answer that you need. 4 and 14, 7 and 8, and 2 and 28 is our answer. So that brings us to step 4. Now, this is where, up until now, things are very straightforward. And this is steps 4, 5, 6, and 7 are really about getting to step 7. They're kind of artificially created so that we can get to step 7. So it's really important that you understand this is just a procedural thing. It's just a process thing. And that when we get to step 7, there's a really important reason why we have it like that. So step 4, what we do is we replace b with those two factors. So instead of writing 30p, we're going to write 2p plus 28p. So notice that if I added these two together, I'd get 30p. So it's the same thing. It's an equivalent expression. I haven't really changed. Hey, Rarity. Rarity's my cat. I'm not just losing my mind. Well, I'm probably losing my mind a little bit, but I'm also petting my cat while I'm doing it. So, 2 plus 28 is 30, which means we're not actually changing the value of anything. We're just writing it differently. Number 5 It says to group it using the associative property. We're grouping the first two and the last two. Boom, 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 boom. And yeah, that's it. Step 5 is simply writing 2 sets of parentheses. For those of you who are wondering, a single one is called a parenthetical. And there you go. So, step 6, we are going to factor out the greatest common factor. Kind of gave it away there. It's P. But let's look. So what you want to do when you're doing the greatest common factor, you want to look at the numbers, the coefficients, and you want to look at the variables. So 7p squared and 2p. Well, 7 and 2 are both prime numbers, so they're not going to have anything in common. P squared and p, well, I can take one of the p's out. So what am I left with? Well, if I take a p away from 7p squared, I'm left with 7p. If I take the p away from 2p, I'm just left with 2. So then that gives me p times 7p plus 2. Notice that if I redistributed that p, I'd get back to 7p squared plus 2p. But we're not going backwards, we're going forwards. Okay, so now we have 28p plus 8. 28p and 8. So let's look at the 28 and the 8 first. We look at our numbers first. So I know that 28 is like 7 times 4. I know that 8 is 4 times 2. So I can pull that 4 out. And lo and behold, what am I left with? 7p plus 2. Now notice that we have the same binomial there. And that's really a key component here. So once you get that first binomial, you can kind of look. So I knew that I had p times 7p plus 2. So going into looking for the greatest common factor of 28p plus 8, I'm going in with the knowledge that once I pull out that greatest common factor, I really should be left with 7p plus 2. I know that's a little backwards, but if you understand that, then you're well on your way to getting this. So, that was step 5 was the grouping. Step 6 was the factoring. Step 7, we're going to factor out our common binomial. So we factor out the common binomial, and what are we left with? We're left with p plus 4 equals 0. Now, this is what all the work has been for. What we've been trying to do, because you can't solve just kind of willy-nilly for an x squared. I can't solve for x. When I have x squared, when I have, here it was 7x squared plus 30x plus 8 equals 0, I can't isolate x. Because I've got an x squared and an x. I can't put them together. I can't add them. I can't subtract them. So there's no way that I can simply isolate my variable. So people who are much smarter than I am came up with this process of factoring. And what this does is it allows us to boil the problem down to this multiplication problem. So remember back in Algebra 1 when you FOILed things? And in one of my classes, someone said, well, if we just multiplied those two together, we'd be back where we started. Exactly. So what we're doing is we're pulling apart a quadratic equation. And we get this multiplication problem of two binomials multiplied by each other. And now that they're multiplied and equal to 0, we can use the zero product theorem. Which means we can create two separate, whoa, I just got really tired. We can create two separate equations and solve those. So we get p equals negative 2/7 or p equals negative 4. The reason we can do this is if I know that I multiply this number times this number and get 0 right there, well, the only way for it to do that is if one of the two numbers or the two terms I'm multiplying is 0. I can't, in order to get 0 as a product, zero product, I need to have one of the factors be 0. That's the zero product theorem. So this whole rigmarole, this whole thing of multiplying a by c and factoring out b, blah, 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 all of that is simply to get to step 7, so I have a multiplication problem equal to 0, and then I can use the zero product theorem. And now I've solved the problem. Okay, next one. Which one are we doing? Let's do number 13. So notice here we have that negative 47x on the other side. We have to put this in standard form. So I'm going to add 47x to both sides. And this gives me 7x squared plus 47x. Whoa, don't look. You'll see the magic before it happens. Okay, so now we set up our quadratic equation. It's in standard form, x squared plus bx plus c equals 0. And we went ahead and we filled out a, b, and c. A is 7, b is 47, and c is negative 14. Step 2, multiply a by c. We get negative 98. Okay, now notice what I'm looking for here in step 3. I'm looking for the factors of negative 98. So two numbers who, when multiplied together, will equal negative 98. And I'm looking for the sum of those numbers to be 47. Okay? So now notice that because when they multiply together they're a negative and when they add together they're a positive, that means that I have numbers of different signs. I'm going to have one negative and one positive number, and the positive number has to be bigger. So when I have 1 and 98, I know that 98 would have to be positive. But when I add those two up, I get 97. So then I go negative 2 and 49. Hey, that equals 47. So I'm done. I now rewrite my initial equation, but instead of writing 47x, I write negative 2x plus 49x minus 14 equals 0. Step 4, that's step 4. I now group. So now step 5, we group them together. And then we pull out the greatest common factor, 7x squared and negative 2x. Again, 7 and 2, exact same numbers as last time. Both of them prime numbers, so we can't pull anything out. We have an x squared and x, so we can pull out an x there. And we're left with 7x minus 2. Again, now we know we're looking for a 7x minus 2. Well, what do I have to pull out of 49x to get 7x? Well, it's a 7. I look over at negative 14. I can also pull a 7 out of there. And that makes sense because I know 49 is 7 times 7. 14 is 7 times 2. So I can pull that 7 out. And what am I left with? 7x minus 2. So if I get the same thing here and here, I know I'm on the right track. So I'm going to factor out that 7x minus 2. And I'm left with an x plus 7. Again, this is the whole point of the thing. Trying to get to that multiplication problem which has 0 as its product so we can use the zero product theorem. We set both of these equal to 0. 7x minus 2 equals 0. X plus 7 equals 0. Solve them both. For the first one, we add 2 and then divide by 7. So we get x equals 2 sevenths. Second one, we just subtract 7. And those are our answers. Okay. Last one. I'm going to do number 18. And by 18, I mean 20. So I'm adding 25x because, again, it is key that we start off in standard form. We need to be in standard form for this to work. So I have 3x squared plus 25x plus 28. Identify a equals 3, b equals 25, c equals 28. Multiply a times c. 3 times 28 equals 84. Factors of 84. Now notice here that because they're multiplied together to equal 84, and then they add up to 25, both of those positive, I don't need to worry about negatives. They're both going to be positive numbers. So 1 and 84, 2 and 42, 3 and 28, 4 and 21. Now I know that's my answer, but I'm going to keep going. 6 and 12, okay? So I have 4 times 21, so I'm going to rewrite the equation. 3x squared plus 25x, but instead of 25x, I'm writing 4 plus 21 plus 28 equals 0. Group them up for step 5. Greatest common factor for step 6. 3x squared plus 4x. Well, 3 is a prime number, so it only has 1 and 3 in it. 4 has 2 times 2. So they have nothing in common number-wise, but they do have an x in common. So we're going to pull out an x, and we're left with 3x plus 4. 21x, well, I know 21 is 7 times 3. Plus 28, I know 28 is 7 times 4. So I'm going to pull out a 7, and I'm left with 3x plus 4. Factor out the 3x plus 4. What am I left with? Boom, boom. I'm left with x plus 7. And again, I know you're probably sick of hearing this. This is why we go through all this. We go through all this so that we get this multiplication problem. Because this multiplication problem allows us to separate the x's into 2 separate equations and allows them to use their algebra skills to, them being you, to solve it, okay? So we now have 3x plus 4 equals 0 and x plus 7 equals 0. I'm going to subtract 4 divided by 3, so I get x equals negative 4/3. And I'm going to subtract 7, so I get x equals negative 7. And those are my answers. Now, if you're wondering what those answers mean, all quadratic equations form a parabola when we graph them. So what these zeros are that we're finding, what these answers are there are zeros. There were x equals 0 or y equals 0. So at what x does y equal 0? So here we have negative 7 and negative 4/3. So the graph would look probably something along those lines. So when we're finding these, it's really important because for about the rest of the year, we're going to be talking about isolating things and finding zeros and all sorts of fun stuff like that. So that's it for tonight. Have a wonderful evening, and I hope to see you guys ready to go and learn about completing the square tomorrow afternoon.